Welcome back. So in the previous video, we basically got a glfw up, but we didn't really do any WGPU stuff, and that's going to be the topic today. By the end of this video, we're going to get a WGPU context sort of running. We're going to connect it to our glfw window that we made before, and yeah, that's it. There will be a lot of typing here, and a lot of this will be sort of boilerplate stuff, but I think let's get into it. So we'll go over to cargo and we'll declare that we're going to use the WGPU crate. We save that, and then cargo does its thing under the hood to load that crate in. While it does that, I'm going to make a struct which will hold everything that we'll need to do our programming. So the old Rust dance, as they say. We've got this surface, and WGPU is saying, well, if you're going to make a surface, you need to specify that we expect this surface to hang around for a while. That's not going to be something that we're going to be continually like swapping out. And the way I'm going to do that is I'm going to specify, okay, let's say the state is expected to hang around for some scope. The surface is expected to hang around for, the same lifetime. Okay, cool. So to briefly talk through this, an instance is sort of we could think of it as a handle to the whole context, if you will. Have a surface which we'll be presenting to, and that surface will essentially be targeting the glfw window. We'll have a device which is abstracting our GPU. We'll have a queue where any work is submitted. To work with the surface, we'll need to have a surface configuration, and that'll be useful later on when we want to reconfigure our surface. Because let's say the glfw window has been modified, we then need to change the surface configuration and then use that to configure the surface to make sure that we're always accurately targeting our glfw window. That just is how it is. Then we have here the size of the surface, and then we have a mutable reference to the window itself. Cool. So far so good. The next thing we'll do is we'll write a lot of functions, but mainly the constructor. Anyway, so I'm going to enter into the implementation scope. The first thing we'll use is we'll have our constructor. So here we've gone ahead and constructed our instance, pretty much like we've done many times before in many different APIs. We have a descriptor object which holds a bunch of configurations. We set that up, we use it to make the object. Here's the bit where things get interesting. What I want to do is I want to go instance create surface. Now, in order to call this function, I need to have sort of a surface target which is built for some sort of window. And so in order to do that, I'll need to make a target. So I'll say, alrighty, my target is I'll go WGPU. I can make a surface target. And then for the surface target, I'll need to specify some sort of window, just like that. But we do get some weird things. So long story short, not entirely sure why this is not working as expected, but it's easy enough to fix. What I can do is I can use the unsafe version. I'll just need to wrap this up. Oops, and there's one more thing that I missed. That's from window. Okay, cool. So this has given me some sort of result. I'll then go ahead and unwrap that, and that will give me what's called a surface target unsafe, just like that. So what I'll do is I'll then use that. So I'll go create surface unsafe. And similarly, I'll need to wrap this in an unsafe block. Just like that. So that's the hard part. And that's a good afternoon's research, trying to get that to work. So again, what we're doing is we are putting in the window. We're abstracting sort of a target to that window, an object which can target that window. And then we are using that target to then create the surface. And this just sets it up so that when we render to that surface, it ends up, the result goes onto that window. It binds onto the window. Okay, great. So what we've got here, an adapter similar to, Vulkan, is a physical device. Basically, it's the actual GPU. So we sort of request that, and then we'll create the device, and the device will logically abstract all that info together. Okay, so there we go. Now I've just realized that this adapter request is an asynchronous function. So what we'll need to do is we'll need to wait for that asynchronous function to finish and then get the result from there. Which of course, as you would know, this is going to be a problem because when we introduce asynchronous stuff, we need to specify that the function is an asynchronous function. Let's do that for now. So we'll get back to that in a second. Okay, so like I've been saying before, we have the adapter that we request, and then we use that adapter to get a device. Now, similar to the window creation where we got both a window and an events queue, the only similarity is we're getting two things. But anyway, this gives us a device and this gives us a queue on which we can submit work for completion. Okay, cool. So here we're setting up our surface configuration. A lot of just standard stuff here. We're going with some sensible defaults. Maximum frame latency is sort of the number of frames that we can have queued up in action at the same time. I just wanted to go with 2. So what we've got is we're almost done with this setup. What we can do is we can then get the surface and go configure. We need to put in our device and we need to put in the surface configuration object. And you'll see that we'll be using this again in the future. But we are almost done. We'll just need to return an instance of the self struct. We'll just put this stuff in as before. Cool, and then we'll just go back up the top. There we go. Okay, cool. So this thing returns a state, and here we initialize and return it. So there are some other functions that I'm going to write. What I'll do is first up, I'll write the next most complicated function, which is the rendering function. So what I'm doing here is I'm essentially just grabbing the surface texture that I'm going to render to and creating an image view of that. Now, there are probably more sophisticated ways to do this. For instance, just upon update, or once upon creation, and then every time upon update, grabbing that texture, but I'm happy with this. A command encoder is an object which encodes draw commands. We'll be using this in a number of times to record draw commands. At the moment, we're just going with the classic start stop. So very simple at the moment. So what I've got here, again, just a chunk, a whole chunk of boilerplate, but this is essentially setting up the clear color for the screen. Okay, cool. So here we are, we're going through the standard stuff. We go and begin the render pass. We then go and finish the render pass. And as you would know, just simply beginning the render pass flushes the screen out with this color, flushes the surface out. Then we go ahead and present. This will put it on the screen. Now, WGPU is complaining and says, hey, here you attempted to get a texture to render to, but this could pass or fail. And so what we need to do is return some sort of result. Either handle it ourselves or make sure that this function returns some sort of result. And that's what I'll do here. So I'll say, okay, this is going to return and what this template is saying is, okay, great. If we succeed, then just indicate a success. That's fine. But if we fail, the type of error that we expect to throw is a WGPU surface area. So what we can do is when we go to render, we can be expecting to possibly get a WGPU surface error in this case. But what I need to do is just get right down the bottom and say, well, if we got here and we're fine, then just pass back that success. So now some slightly simpler functions. So again, we have our initializer, makes a new window. We have our render function, attempts to render to the screen, might throw an error. There are two more functions we need. First up, we may need to resize the screen. That's pretty much what we expect. We remember our new size, we just alter our surface configuration and then we go ahead and configure our surface. Cool. The next thing we'll need is we need to update the surface, because when we resize, that goes ahead and configures the surface. We may need to also grab a new handle to the surface. If the glfw window has modified, we may need to get a new target to it. And actually, I'm going to grab the same stuff that I had right up before in the initializer. So finally, onto actually using this stuff. So we'll just go right down to our main function, and just the same as before, or just the same as you may have seen in many other tutorials, because this stuff is starting to get asynchronous, or at least we've definitely got an asynchronous constructor, we'll now need to have an asynchronous function to run that, but to do that stuff. But this will be a problem because the main function cannot be asynchronous. So I'll just define a main function which will go ahead and kick everything off. And what I'll do is I'll bring in the pollster crate, because I basically need to block the main thread while that asynchronous, because the whole function in the background now counts as asynchronous. So I'll basically kick off the run function, and the main thread will be waiting while that does its thing. Standard pattern. Okay, cool. So anyway, the main function is asynchronous. Now how do we actually do this stuff? Well, just after we've created everything, we'll go ahead and actually, I changed my mind. I'm going to do it after here. Okay, so now because I've given the mutable reference of the window to that state, we can't really use the window the same as we could before, but we can still get the window by accessing it through the state struct. Right, so super simple, just the simplest thing I can think of. Okay, again, so simplest thing I can think of. All I'm doing is creating the state, every frame telling it to render. I'm not even handling errors at the moment, I'm just printing them out because I just want to see what sort of errors we can get. Let's cross our fingers and see what happens. Okay, so very interesting thing happened. For one thing, the surface is about a quarter of the size of the whole thing. It's half in every dimension. Now this is a Mac specific thing. It's sort of like super pixel resolution or something. It reports that sizes should be double or half, or it's strange. And the way we fix that is, again, you may not even get this, but here's a more robust solution. We go to the new function, and then here when we get size, instead we can call get frame buffer size, and that will get the actual physical pixels of the window surface. So then if we were to run this, we're now getting the full thing. There are a few other situations. So one thing, remember we have that resize function. If we resize right now, oh, it's not printing anything, but it's definitely going black. So what I can do, yeah, capture two errors, the lost and outdated. Lost means, I don't know, where did it go? We lost it. But then outdated is a case where the surface that we're rendering to is not the current surface of the window, basically. In these cases, what we can do is we can, and then it's a bit of a hack. I'm just going to force that reconfiguration to happen again. Something like that. Okay, so now we can go ahead and run this. I've got the surface and I can resize it. That's not great. Oh, okay, that's fine, because there's another thing that I need to do, and that is up here I can go and I can intercept a resize event. So I can go glfw window event frame buffer size. Okay, great. So that's handling the resize event. Now what we will need to do is right up here where we've got the polling enabled, I'll go window set the size polling, so that when we resize the window, it does register that we've got that. Okay, so now I'll go and run this again. We've got the window, we can resize the window, and it rebuilds it. Excellent. And there's just one more thing, And this is sort of a funky thing. I think this is Mac, but you'll see here when I move this, suddenly the surface disappears. I can resize and it rebuilds, but it can't handle a position change. Okay, so I found a way to do this. It's not perfect, but it more or less works. And in a game situation, I don't know how many times someone's going to be moving a window around. But anyway, so there's another event called a pause event. So I can go window, set pause polling. And a pause event is triggered anytime a window is moved. I'm just going to use the same trick as before. So think of it as when we move the window, it turns out that the render target does get invalidated. And it's sort of like, yeah. It's sort of like it changes around. It's got the same size, but it is like invalid. Anyway, so fingers crossed, we can now run this. And we've got our window. We can move it just like that. And you'll see there is some slight flicker, which I'm not 100% sure what's going on there. I tried a few things. Maybe I need to try a few more. But yeah, I'm pretty happy with that. So this has been sort of a brief look at how to set up, oh my goodness, that's so big, how to set up a WGPU context and do some basic like screen clearing, window event handling on that context. Cool. Anyway, hope you had fun. In the next video, I'm going to be revisiting shaders, and I've decided that I am going to re-record that video. Even though I did it before, I'll just do it anyway. Okay, so anyway, so that will be it for now. I hope to see you again in the next one. And yeah, all the best. Bye.